Welcome back to our Learning Lab, Module 3. We're going to do the second part of Geometry of Motion, looking at similarities, congruence, and how we can determine whether two objects are what we call similar, and what we mean by that. So let's go ahead and get started right into our lesson. So what is similarity? When we made triangles with all three angles the same, we got an equilateral triangle. And it doesn't matter the size we made, all those triangles we could call to be similar. Okay, so there could be smaller versions or larger versions, but they all have the same 60 degrees for all three angles. That's an equilateral triangle. So that would be a similarity. So when they're the same shape but different sizes, then that's what we call similar. Okay, small, make it large. Okay, but the shape itself has to be the same, so that all we're doing is shrinking. We're not transforming it somehow, like with silly putty. I don't know if you know, when we were kids, you put the silly putty on the comics and then you stretch it, and you could really do all these kinds of strange things to your drawing. But similar. So here's our little friend Spot, and we want to determine which of the other drawings of Spot are similar. So what do you think about this one? Well, was he just shrunk? It looks like he was shrunk down vertically, I guess. But no, I wouldn't call that a similar spot. It looks different, right? So that's not similarity. How about this spot? No, he was kind of squished in from here, so this is smaller, but the top wasn't. What we need to do is whatever we squish in from here, we have to squish in from here, so then Spot will look exactly the same, but smaller. There we go. There is similarity. That's what we're talking about. Okay, so again, we can give and notice this time we took a little different tact. We defined it with words first, and then we went through an exploration of what is similar. Okay, we can do both. And again, as teachers, that's where your power really comes in, is deciding with the particular students you have how to sequence a lesson. Do you start with the definitions first and then explain it? Or do you give them an activity to work through and then give them the words later? How do you sequence your activities? You're the one that can decide best as you get to know your students. So once we can see that two objects are similar, there's a couple different ways we can sort of define it. So we take a measurement. If these are two similar items, and this is, say, 3 centimeters, 3 inches, 3 somethings, then this one has to be 3 times something. Okay, and we call this little letter K, we call that a what's the big word, a coefficient of, I don't know, it's a multiplier. So if it was twice as big, it would be K would be 2 times 3, so it would be 6. If it's 3 times as big, it would be 9. But it's a multiplier, and it can be a decimal, it can be a fraction. 0.5, it would be, so we can do a similarity where it's shrinking down or getting bigger, or we can do 1.5. So 1.5 times 3 would make it 4.5. Okay, so there's all these different things. Similarities, we can do it sort of continuously. It doesn't have to be an integer value. So that's the first idea of similarity. The lengths and the sides are proportional. Okay, and if we knew how high it was, it would have to be that same proportion. So whatever this multiplier is, it would also be the multiplier for the height. So let's take a look. We've got a photo, our cute little kitty. It's a 2-inch by 4-inch, 4 inches high, 2 inches wide. And we've got this canvas, we're going to paint it on. We've got a 16-inch wide canvas. So how tall would we need to make that canvas in order to fit our cute little cat on there? Well, if this is 16 inches, notice we got the big cat now, we need to make it how much? Well, there's kind of two ways to go about this. One way would be to say, well, take 2 to 16, or 16 divided by 2 is 8. However you want to do the math, 2 times 8 is 16. So that's what had to happen. I got to do the same thing to 4. So that's using that multiplying by k idea, multiplying by some kind of a constant. So I need to do the same thing. I need to take 4 times 8, and I need to get 32. So if it's going to be 16 wide, I need to be 32 high. That's the concept here. So that's called using a scale factor. I guess that was what I was, coefficient of whatever, of sizing. A scale factor, making it larger or making it smaller. And notice we could go back either way, so we could take 16 divided by 8 and we can make it smaller if that's what we were looking to. So, but 8 is our scale factor. Okay. There's another approach we could use this, and we could look within the drawing itself. So we can just say, well, 2 to 4, this ratio between the height and the width is 2, right? So if I take 2 times 2, I get 4. And so the idea was I take 2 times 16 and I should get the height. Okay, so that's using a ratio approach. 16 times 2 gives me my 32 as well. And again, sometimes it doesn't really matter. In this case, it was probably just as easy to use either approach. We're going to look at 2 examples, and sometimes one approach is just a little bit easier for us than the other. And again, when we use this word easier, it depends on how we see a problem, how we see the world. And so for us, it might be different than for someone else. What we find easy might be different than what someone else finds easy. Okay, so which method works best? Maybe instead of using easier, which is the most direct for us in our thinking. So we have a stuffed animal company wants to make an enlarged version of a Piper stuffed bunny. The original bunny is 6 inches wide and 11 inches tall. Now, we're going to enlarge the bunny to be 33 inches tall. How wide will it be? So take a look at that. Try what would be your factor if you tried the ratio approach? Well, then it's got to be 6 inches to 11 inches. That ratio is, it's not an integer value. It's maybe harder to work with. It would be decimal. But the 11 to 33, well, 11 times 3 gives us 33. So 11 times 3, so 6 times 3 gives us our answer. 6 times 3 is 18. You see, we could do that one in our head. If we go to the ratio approach of 6/11ths or 11/6 and then try to apply that to 33, the ratio approach in this case is, it would give us the same answer. It should give us 18, but it's a little more difficult. In fact, for me, yeah, I'd have to break out some paper or calculator or something. Whereas when I use the scale factor approach, 11 times 3 is 33, so 6 times 3 is 18. That I could do in my head. But on this one, a toy company wants to produce a scale model of a car. The actual car is 6 feet wide and 12 feet long. 12-foot car. That sounds kind of cool. The scale models will be 2.5 inches wide. How long should? Well, so see, you can see here the difference between the width and the length is an integer value. 2 times 6 is 12, and 12 divided by 2 is 6. So I could then just multiply this by 2. I don't have to try to figure out that what is the ratio between 6 and 2.5. That one is, again, I'm going to have to bust out some paper or a calculator or both. Whereas when I use the ratio approach here, comparing the 6 to the 12 and getting the 2 times 2.5 is going to give me 4. That's going to give me 5. Okay, see, I could do that one in my head by using the ratio approach. And for the ratio approach, the missing part, we can often use something called a proportion. We set the two sides, two fractions equal to each other, and then it makes solving for the unknown a little more straightforward. So how many of you thought about solving the previous problems? So we could set up the proportions, right? The thing is with proportions, there's always multiple ways. So we could do 11 to 33, and that's where we maybe get our 1/3, or you could even put the 33 on top. So there's multiple ways here compared to 6 to 11. The thing is there has to be this direct connection between items of the same figure. So in this case, 11 and 6 are from the same figure, and then 33 and x would be from the same figure. So it's kind of a horizontal matchup that way. Okay. We could also say 6 over 11. This ratio approach, again, doesn't give us a nice integer value to work with. If some kind of repeating decimal, it's hard to work with, but we could still solve it in this fashion. And again, the 6 is to the 11 as x is to 33. Okay, so the 11 and the 33 are related because they're both the, I think the height or the width, something. And then the 6 and the x are the same feature of the drawing. Okay, so multiple ways to set up a proportion. And then when we have proportions, oftentimes mathematically what we do is we cross multiply 6 times 33, and then you'll end up dividing by what I call the odd one out. So the diagonals get multiplied and then divide by the other one. So notice here you're still taking 33 times 6, dividing by 11, and that will give you your value, your missing value. And the other problem we could have done with the ratio as well. Again, the 2.5 relates to the x as 6 relates to 12. Those are the similar ones. So this is a ratio of similar items on different drawings, or we could do the different dimensions on the same drawing as a fraction. We just need to make sure everything is that. Notice with the 6, the 12 goes with the drawing figure, and the 2.5 goes with the same dimension on the smaller object. So we can use proportions in this way. And that's our lesson for today. So let's take a look at the activities we have for us. Let's see, we are going to do similarities, congruent similarity. So what we're going to have you do is draw a map of following this. And we're going to use similarities. Notice a scale factor, 10 miles is equal to 1 inch. So each inch is equal to 10 miles. And here we got 20 miles. So what? That needs to be 2 inches, right? 30 miles needs to be 3 inches, and so forth and so on. So you can, again, print these out and then draw them. Let me come back and get my screen back up here. It messes things around there. Let me move this over. Sorry. You can go ahead and print this out, use a ruler and a pencil and do it. You can also use the tools we have, that drawing tool we used before with the pencil and compass. I don't know that you need the compass, but it might prove helpful. Anyway, you could do this in multiple ways. You can also use the drawing tools here, but let's see. I don't think, is there a ruler? I think there's a way to get a ruler. If you go to view, here's a ruler up here. So you got the side rulers, and you could have these in inches. So you could see, then when you go to your draw tool, actually you may want to go to your insert a line tool, but you could kind of line this up, and then we want to go maybe 20 miles over. That would be over here, and then you could label it, there's 20 miles. So you could do it electronically or by hand. Let's see, what else is there? Let's look at the rest. And then a discussion about how is it different. Then we've got you drawing a flag using both a scale factor, aspect ratios, and proportions. So these are, again, the ratio and proportion method may be similar, but we just want you to solve the same problem in multiple different ways. And again, as you do that, kind of feel personally yourself, how does each one feel? Does one feel easier than the other, more natural than the other? Are they equally? But at least you get your experience that there's multiple ways to do things. And that's very important to do, is to learn more methods, because that will help you in working with your students. You won't be forcing them into doing just the one way that you understand. If you can understand things in multiple ways, then you can explain them in multiple ways, and you can help your students who come up with interesting new ways of doing things. Okay, here's one with a scale drawing, and here's another drawing, and okay, so here's a scale drawing, and if the kitchen's 10 feet, what is the dining room? You can use that, and then scale train using this sort of these factors, and you can convert those over. Okay, so that's what we want you to do. The other activity we have you doing today is, come back here, is a tessellation. And again, all the product that you're going to upload to me is just your end result. It should take you, you got to get everything together, probably 45 minutes. Could be less if you had everything. You have some scissors readily available. There's a equilateral triangle. There's a video for you to watch. The reason I use that video, I was thinking I should make my own, but hey, that guy does a pretty good job of making it exciting, and he's an elementary teacher. And that's the same video I used 10 years ago when I was teaching summer school in Kazakhstan. And I came up with this activity that was interactive for the students to learn geometrical tessellations. And so you'll see below, if you go down, so you've got the video to watch. It's 9 minutes, I believe, or so. And this teacher takes you through the activity, walk through the steps. There are some triangles, a printout. You can print it out and cut it out, or you can make your own equilateral triangle and then follow the directions that he gives you. Below that, I've given some pictures that I took from my class in Kazakhstan of them kind of constructing this this tessellation drawing, and then some of the finished product that I got out of it. But they had a really good time doing it, and I felt that it's just a great activity to learn by doing. And additionally, it gives you this access that, hey, we can look online for all these free ways of explaining things. And if you look at this video on YouTube, there's other people who've done a similar thing, some more straightforward. I've seen that the discussion or the description done in as few as like 2 or 3 minutes, but I like the energy of this guy. Okay, but again, that's 10 years ago. There's probably other people have made it. So do those activities, and we'll be ready to go into our next module, Module 4, when we come back together. So let me know how this all works out for you. Remember, I'm available. Just contact me by email. We can make appointments through Zoom, through just getting our schedules to match up. Okay, take care, be well, and have a wonderful day.